All right, I think we've got people trickling in, and we'll get started soon. We're at 17 heads. I see Alex. One of our speakers is here. Uh, Ritu, are you in the office there? Is that you? Yes. Okay, cool. We're zooming out, zooming out.
Do we want to do a mic check in the room, Curtis?
Probably advisable, although I think that might be what the staff just did. I show up on the camera in there, mayhaps. All right, we're at 20. We should get started, I guess. Um, welcome everyone to the GAIA for IETF 123. As you can see, I'm in a hotel room in Toronto. I'm at the ACM Compass conference right now, and it's a little bit early in the morning, but I'm glad to see all your shining faces. And I'm annoyed I couldn't be there in person, but always glad to bring this community together and bring interesting speakers in to kind of provide some different perspectives on what's going on at the IETF and the internet in general. Um, so we have 3 speakers up this particular day. If you're interested, you can go see the agenda that we put up in the data tracker. Um, and as per our usual format, it'll be 20 minutes of talk with 10 minutes of Q&A. So bring your questions. We try to make a lot of space for that because I think that's one of the most interesting things that happen here at GAIA, or nice back and forth discussions with these people building or engaging with the internet in new and unique ways. Um, in terms of announcements, the big one we have is that we are bringing a new co-chair in to GAIA. This is Adisorn, who you saw most recently at the IETF and GAIA in Bangkok before this one. Again, the time zones are so rough. Adisorn's not able to make it this particular event, and also he has a nice new baby. But we now have these 3 co-chairs: myself, Jane, and Adisorn, and we're hoping to get some good coverage all the way around the world through the 3 of us, and keep bringing some interesting folks in. Jane, is there anything that you think we should add?
No, that's perfect. Hi, everyone. It's Jane. I'm a little under the weather with, believe it or not, COVID. So I'm in the U.S. In the East Western Hemisphere like Curtis. Just really excited to see Adisorn join our crew, and I'm excited to hear everybody today. So over to you, Curtis. Thanks.
Yeah, I guess we can get started with Alex. Alex, are you available? We can give you um, slide control and stand up some of your slides. So let me first do that. Um, can we get confirmation from the room that people are seeing the Crane Cloud slides from Alex? Thumbs up. Great. Oh, look at that Crane Cloud slide. That's beautiful. And similarly online, I'm seeing them, but I assume.
All clear.
All clear. All right, and we heard that one. Let me pass slide control to Alex. Alex, you should be able to move slides around. Let's confirm that, and then I think um, you should be able to jump in and speak.
Thank you, Katis. I hope you can hear me.
You're a little bit quiet. Can you turn anything up on your side?
Okay, are you able to hear me now?
Yeah, that's better. And maybe just if you're a little bit louder personally, it'll help. If anyone in the room or online is struggling, please make a mention in the chat, and we'll see what we can do. Um, so let me introduce Alex. Um, Alex Motel is a PhD student at Macquarie University. Um, and I got to know Alex through him spending some time at the University of Washington as a visiting student. Um, and I've been working with Alex for a while, and I got to know this Crane Cloud project um, from him and his advisor, engineer. And I was really excited to bring it here. It seems like a great project to talk about at GAIA. So, all right, Alex, the floor is yours.
Yes, thank you, Katis, for that. And I think I will just briefly enable my video or camera, and then I will just shortly disable it. I hope you can see me. Yeah, and I am Alex Motil, here in Kampala, Uganda. Like Kathy said, I'm a PhD student, but also I have been working with the Crane Cloud project for quite some time now. And it is a pleasure really to speak to you about Crane Cloud, what it is, and what we have been doing here. I will just disable my video for now, but then later on in the Q&A, I will just enable it. Thank you. Yeah, so this presentation, we will briefly look at the background to the Crane Cloud project, looking at some of the challenges of operating and using cloud services in settings such as ours here in Uganda, and the motivation, of course, for Crane Cloud. We shall also have a look at the high-level architecture of Crane Cloud, the services that make up Crane Cloud, and what it offers to its users. We also look at some analysis of usage on the platform that will try to showcase where we've come from, where we are, and perhaps where we are going. So a significant percentage of content in resource-constrained setups, such as in Africa, we know, is hosted outside the continent, with some sources reporting even over 80%. This is partly because the digital infrastructure that is required for fast, affordable, and reliable internet services is quite underdeveloped. This means that even simple online interactions require data to travel thousands of miles. Introducing high latency, this contributes, of course, the slow access speeds that we often witness here. But we also realize that for a university like Makerere, there are a number of projects. And what these projects were basically doing is that in their budgets, they would have like an item for, or at least an amount for like server equipment. And so in the survey that we did, we realized that most of the server equipment that they had obtained were was being underutilized in a way. We also note that in these settings, the bandwidth remains limited. It's also expensive. That means that the cost of accessing cloud-based services, especially those with the public cloud providers, is often very high, especially for institutions, for startups, and small businesses. Another major concern that we often encounter is the vendor lock-in, where we find that users become dependent on specific cloud providers' ecosystems, and that usually makes it difficult to move to even alternate um, platforms.
Hey, Alex,
This,
there's a request to be a little bit louder. I think the room is having an issue hearing you.
Okay, let me see what I can do in my input volume. Let me just make that to the
Okay.
maximum. Is it better now?
Um, I don't think I noticed too much difference.
Yeah, maybe people in the room, are you able to hear me better now?
Hey, yes, a bit, but you really have to speak up. It's really hard to follow here in the room.
Okay, I've put a note in the chat for the colleagues at Meet Echo because we may not be able to control the room sound from here.
Yeah, I'm looking at all the buttons, hoping for something. Yeah, I guess Alex, just be as loud as you can in your room. Hopefully, you don't have anyone sleeping uh, there with you.
Yeah, I'm here alone, and can maybe I can try again and be a bit more loud. I don't know if that will help or that helps actually in the room.
Much
This,
better now, much better now.
yeah, this sounds much better. Yeah, great.
Okay, perfect. Yeah, so I will just then repeat from this introduction. So I was basically saying that we, from research, a significant percentage of content in resource constrained setups such as those in Africa, and especially from some of the tests that we've also done here and research that we've done here, shows that more than 80% of content that is even consumed locally here is hosted outside the continent. This is because the digital infrastructure that is required for access is underdeveloped. It also means that simple online interactions require data to move thousands of miles, that introduces high latency and contributes to the slow access speeds. Even with the local infrastructure, especially from a study that we did within Makerere University, we realized that there were many servers that had been bought by different projects, but most of them were being underutilized. Also, the bandwidth, internet bandwidth remains limited and expensive in our region. The cost of accessing cloud-based services, especially those with public cloud providers, is often very high for institutions, startups, and small businesses. Another major concern is the vendor lock-in, where now users become dependent on specific cloud providers' ecosystems that make it difficult and costly to migrate to alternate platforms. Also, the control over the infrastructure and data becomes limited in such settings. There are also gaps in the local capacity and the technical skill set that may be required to manage and operate a cloud platform. This leads to reliance on external expertise, which can also be both expensive and unsustainable. Lastly, privacy and data sovereignty remain pressing issues now in Africa as more personal and institutional data is stored on foreign servers. Concerns on misuse and compliance with local regulations also grow. What are the implications here? Due to, again, the long distances that the data must travel to servers in Europe or North America, users experience high latency. This averages 160 milliseconds to Europe and 289 milliseconds to the Americas, as measured again from Kampala, Uganda here. Websites have slow load times, laggy applications, audio video calls, always buffering, and this leads to overall degraded performance. We also notice that there is very limited infrastructure for systems or network research here. And without, of course, these test beds, it's difficult for researchers and students to conduct experiments in these fields. And so we can't easily be able to, for example, come up with, say, protocols that speak to the constraints of our region. The I upstream data costs, which could be in the ingress and the ingress and the egress, because of the data routing that has to happen through so many international links, incurring, of course, high transit costs. These expenses will now ultimately pass down to the end users. That make really these services very less affordable and limits the access. Reduce digital sovereignty, again, like we've just talked about, barriers to innovation, because now with our developers and startups that may not even have, say, credit or debit cards, they may not be able to easily access affordable, accessible cloud platforms that they can use to build, test, and scale their products. And this limits, of course, again, some homegrown solutions and also local digital entrepreneurship. Finally, students in African universities, for example, often don't have access to the same tools, same platforms, or real-world deployment experiences as peers in other developed countries. Clearly, this depends the digital divide and affects also our global competitiveness in research and innovation. So this led us to think about Crane Cloud really. And Crane Cloud is a local platform as a service solution that provides developers and organizations with the infrastructure that they need to deploy their applications, manage the data, and scale services with less reliance on other expensive remote platforms. Our vision for Crane Cloud is to provide vendor independent cloud services that meet the diverse needs of, say, government, startups, students, and researchers within the continent. By offering, of course, a ready-to-use cloud environment, Crane Cloud can remove the heavy lifting that is required to launch some software services, allowing entrepreneurs and developers to mainly focus on innovation rather than the requirements of setting up the infrastructure. Also, Crane Cloud, beyond infrastructure, is an educational platform where students, startups, and innovators can learn practices such as DevOps, deployment of real projects, cloud computing, and ability to showcase the work that they have done in a live environment. To talk more about again Crane Cloud, it is a containerized application deployment and management platform. It simplifies the complex processes of running scalable cloud native applications by offering an abstraction layer over Kubernetes clusters. This, of course, makes it easy for users to deploy and manage the applications without having to deal with the layers below, the hardware, the Kubernetes elements, for example. And of course, we provide a number of tools that can be able to also support, as we shall see, elements like, say, deployment, maybe elements of replication, elements of monitoring, and so forth. The platform is backed, of course, by a cluster of compute and storage resources from public, private, and community domains. It also offers a rich set of services that enhance the user experience and support modern application development and deployment. For example, we develop Mira as our automated deployment engine, allowing users to push code and have it deployed seamlessly with minimal configuration on the platform. The platform also supports user and organization management, making it easy to work as an individual or work as a team and collaborate on, say, a specific project on the platform. We also provide managed relational database services, enabling users to provision and manage databases, again, without even needing database admin or setup expertise. Our monitoring tools have or provide real-time observability into application performance and infrastructure health. Our logging services ensure users can easily diagnose and debug issues in their applications, but also from an administrative viewpoint, this enables us to exert more control, more regulatory control in terms of usage of the platform. Most recently, for AI and data science teams, we've been working on our MLOps features that for now support training and deployment of machine learning models on the same infrastructure. Again, contributing, of course, a significant percentage of the work required in the whole ML pipeline work. Crane Cloud is Crane Cloud is of course built based on a microservices architecture with first of all in high level terms a backend and front end microservices. This of course enables us to scale better. Also enables us to work in teams independently and deploy those different components as and when they are required. Our front end is friendly from again some of the surveys that we've conducted, while the back end handles a number of features like orchestration, deployment, and management of the resources. In terms of the infrastructure, Crane Cloud supports integration with cloud providers from different domains. For example, currently, we have bare metal infrastructure at the university, Makerere University here in Kampala. We also have some infrastructure from the National Research and Education Network of Uganda. We also have ongoing discussions with the National IT Authority of Uganda, NetLabs Uganda, and the African Center of Excellence in Bioinformatics and Data Intensive Sciences in Uganda to provide us with more infrastructure so that we can be able to expand our cluster coverage. Of course, we also have an administration layer with role-based access control, multi-tenant management, and as I mentioned, tools for monitoring usage and managing some of the resources that we have currently. One of the core ambitions of Crane Cloud is application portability. As we know that our environment keeps changing, you have clusters that may go off due to power outages, due to misconfigurations. And so at the core of Crane Cloud is portability, ability to move workloads seamlessly across different domains based on need without rewriting or reconfiguring the application. So that means that we should be able to easily move applications from one geographical location to another, across availability zones, between different cost domains, if budget is one of the key factors to consider, and then also across regulatory domains, if in case you want to work with, say, compliance to data restrictions or laws within a given region. Of course, this vision ensures that users are not locked into just like one provider or just one location, or at least should be able to actually work with what they need. So basically, we're saying depending on what matters most at any point in time. From the start, we started this project, I think 3 to 4 years ago, and it's grown in a way. For example, we serve close to 1,000 users now, and these are mainly students, researchers, developers, and innovators within the country. They have created and deployed over 1,000 projects and applications now. This range from web applications to APIs and data services. To support some of these workloads, the platform has provisioned over 350 databases managed directly through the web interface. Again, removing, of course, the typical complexities of infrastructure setup. All of this is running on our 3 production clusters, which form the backbone of our current cloud infrastructure. These clusters are distributed within Kampala here and designed in a way to provide some element of availability and, of course, scalability. Importantly, we recently commissioned a dedicated ML cluster. We got like some servers with some GPUs, and so we've basically created this as our ML cluster and build like new tools to support ML workflows. Like I said, currently we do training and serving of ML applications, and we've tested this most recently with our group of students. Crane Cloud is not just a deployment platform, it's also a learning environment. Through our internship program, we've trained over 40 students, giving them hands-on experiences in cloud operations, DevOps, and software delivery pipelines. Many of these interns have gone on to contribute to the platform itself. But I've also joined like tech teams across the region and the world, and we're so proud of that. We've also conducted workshops, engaged more than 500 participants from universities and local communities, especially within here in Uganda. These sessions cover everything from application containerization, CI/CD, cloud computing in its basics, cloud native architecture, microservices, and the rest really that are part of again the platform, or at least led us into the development of the platform. In terms of the academic curricula here at the university, Crane Cloud has been integrated to courses like cloud computing. The cloud computing course that is being done here uses our infrastructure for demonstrations. We have the DevOps course, and also some other course units in the software engineering again course. Enabling students learn by doing beyond classwork. Many students now use the platform for their final year projects, for their research projects, and they have definitely gained some real world experiences by building and deploying their applications on an actual cloud infrastructure. To conclude, there is a clear and growing demand for compute and storage services, even across Africa here. This is driven mainly by, of course, the digital transformation that we've witnessed, increased data usage, and rise of software-driven innovation. However, we realize that most existing platforms, one, are not built with the realities of the constraints that we have locally here, but also the costs are just so prohibitive for users within our environments. And so Crane Cloud tries to fill this gap by providing the local pass solution designed to lower the barriers to cloud adoption in our settings by enabling students, developers, startups, and institutions to build, deploy, and scale their applications without much reliance on, say, foreign remote infrastructure. We've been able to witness, of course, a platform grow and seen many users signing up and trying out their applications on the platform. Again, as we look to the future, we plan to bring in more universities into the platform so that now they also have a piece of the infrastructure and they can be able to use that infrastructure on top of what we, for example, have already, so that we can have a more collaborative, like distributed infrastructure that can be used by our users. We continue to expand our support for AI and ML workloads, trying as much as possible to keep certain elements of, say, data and service local. And lastly, also, we continue to work on sustainability and growth as we explore more diverse funding sources, including partnerships, grants, and institutions that have the same vision as, of course, these projects. Again, we've seen that Rain Cloud is more than just a platform, but it's like a journey towards digital independence, innovation, and resilience that we hope to see in the near future. Of course, special thanks to a number of our partners who we have worked closely with for the last couple of years, and they have been instrumental in building, of course, Crane Cloud, notably the government of Uganda, which has, of course, given us some research funds, and very, very importantly, the Paul Maris Foundation. Thank you.
Yay, thank you so much. The queue is open. I'm going to use my speaker privileges to jump in the head of the queue. And then we've got a Benson after me. But just for clarification's sake, um, is Crane Cloud just for Uganda, or can other actors, presumably in East Africa or Africa in general, make use of it?
Yeah, so currently, because we've been doing, I would say that our funding has been limited to Uganda in a way, but yes, our plans are to scale definitely. So For now, it's just that the funding has been a bit limited to our operations here, but we would indefinitely have any problem like going into maybe say East Africa or in other place really in Africa. But for now, yeah, I think most of our users are here in Africa.
Makes sense.
I
And
mean,
then
in
the second
Uganda.
quick question is what kind of workloads do you see on the platform right now in these early stages?
Yeah, so in these early stages, so when we set up like the AI cluster recently, we thought we had at least some enough resources in there, but just with a few trainings. So I think we've had like about maybe 50 to 100 users in there, and before we know, we knew. I mean, our resources were quite like really used up in a way. So that to us is what has actually taken up most of our resources. But then beyond that, I think we've had users that are also doing like video streams on the platform. Um, um, Others are just building like APIs. Others are also just working on like simple like web-based kind of applications really.
Okay, excellent. Benson, would you like to jump in?
Thanks for a very nice presentation. I'm curious, what's the size of the cluster in terms of like how many nodes, how many cores? And do you monitor power? And finally, is the power clean? Uganda has a lot of hydropower, so I guess even for companies looking to build data centers, they might get very cheap power in Uganda. So it'd be helpful to know if that's something you monitor.
Yeah, we so one in terms of the resources that we have, I may not be very specific, like in terms of the cores and the memory and all that, but I think I can say that our first production cluster has like about 5 nodes. And then the infrastructure that RENU, the Research and Education Network for Uganda, provided us, I think they're about like again also 5 nodes in there. While our ML1 is just like a 2-node cluster because that's basically where the GPUs like are. Yeah, but then in terms of, I think if I look at probably the cores, our first cluster could be having like about 128 cores. While the RENU cluster, we could be having about like 64 cores in there. So they are not like hyper high in terms of really the resources that we have in those clusters.
Thank you. Do you monitor power? I guess that was the second
Oh
part.
yeah, that was another thing. So currently we do not do that. So one is that the cluster, for example, that is provided by the Research and Education Network for Uganda, we do not have like they just give us like, they don't give us like bare metal plus, I mean, resources really, but they just give us like a provision machine. So we do not have more control really in terms of like power and consumption like that. But then, yeah, we do actually have plans, especially with the clusters that we have at the university here. I know we just use the data center of the university, but I agree with you. It's something that we will definitely need to look into.
All right,
Thank you.
excellent. Thank you so much, Alex. We're going to move on to our next speaker. But if anyone is interested, reach out to Alex for more information. Let's do.
Thank you, guys. And thank you, everyone.
Take back slide control, stop slides, and we'll do. So Adam, we have Adam Burns here to talk about some standards work that they have been doing with Freifunk and other community networks. Um, Adam, the floor is yours.
Okay, thank you very much, Curtis. working out how to, do I have slide control?
You do now, sorry.
Okay, yeah, I was a little confused there. I trust also that I'm allowed enough. Thank you, Jane. All right, seems I am. Okay, hi everybody, good morning to you all. My name is Adam Burns. I've been involved in community network development and deployment for many years in the UK and in Europe, and a little bit of Australia as well. And today I'd like to talk to you about a project that I've been developing called SIG0 Name Control. It's designed to facilitate services to be run internally within community networks infrastructures. Okay, the project uses the domain name service, the DNS, specifically DNSSEC. It also allows distributed ownership and control of the DNS hierarchy underneath a specific zone. We do this using so-called SIG0 public keys that are stored within the DNS zone that allow strong access control to altering the DNS system. This means that participants can request for a new subdomain within a community network or beyond and receive it, and then have total control over the DNS tree beyond that. And this is really primarily to empower people in community networks and edge networks to start to publish and find local resources and digital services in their own network. Specifically, also, it's extremely low, has a low requirements. It can be run on existing services and or even open source routers themselves. And yeah, so a bit on social relevance. It really tries to decentralize traditional central data center infrastructures back out to the edge again. And it offers it in a secure way with the DNSSEC encryption tree of trusted keys. It can then verify further information within DNSSEC publishing. And Freifunk is a German group of community networks, each autonomous within their own region. It has over 20,000 nodes nationally already, and it is a thriving social community also in every area, but we'll get to that as well. The test group that we've started to develop SIG0 in, Freifunk, is a non-profit initiative run by an umbrella group, but as I said, each area and region is autonomous within itself. In Berlin, where I currently live, there are over 500 nodes and hotspots spread throughout the city. And our experiments have allowed Freifunk community to collaborate, publish and make accessible local web resources on their own computers and networks, or beyond, by the way. It's optional, but this easily allows the publishing and the discovery of local services in particular, but it is not limited to. So the design criteria of SIG0 name control, unmediated access to community infrastructures and local services for local needs, minimal resource footprint using existing DNS infrastructure, and lightweight libraries or clients in the clients. Also, the advantages are integrity and of trust within the DNSSEC trust chain, and it offers alternatives to ISPs and big tech services. Although I note Alex, the previous speaker, such a cloud infrastructure could be also easily integratable within these networks. And the system requirements, as I basically said, also platform independent, extremely low system requirements for resource constrained systems such as embedded routers, etc., and capable of close to real-time DNS updates, and secure in terms of the local device that requested the device or person that requests the key holds the private key material. So a brief, brief design document of architecture. There are browser applications for users that can be developed, command line tools for more expert users that can be used either by operators, people who have requested DNS labels themselves, or indeed automated processes that can deal with perhaps DNS transactional automation. And a bit of detail here about the flow of information between a requester and a provider when a new key, a new DNS label is requested. The F60 name control operates on a first come, first served basis for a new subdomain. So if a domain exists, then requests are denied. If domains do not exist, then the key pair is accepted and the public key is published at the particular name in the DNS system for access control. I should note that the policy part of SIG0 name control is completely programmable. So if other policies are required, they can be developed further. And also the work here in Madrid and the previous IETF meeting, finally, the good work of Ted Lemon and Stuart Cheshire within the DNS working groups have finally published some RFCs that will improve the performance of SIG0 name control and remove some of the more custom work that had to be done before these standards were finalized. So how does it work? Well, within, say, a by9 DNS server, it works on a policy base that allows an initial key to be able to do updates within specific zones. And the second part is that requests place their requests in a special subdomain called _signal, which is a temporary buffer place for the admin of a zone to approve or not a new key request. The system automatically, by default, automatically approves it, and it's a script that always looks for new keys within the signal zone for registration, unless it collides with an existing one. But this, of course, is open. And it's so good to see that these this RFC work of 9644 and 9655 are now implemented, and we hope to be incorporating these standards to remove some of the workarounds. Okay, now into some of the web applications that are able to use this that we have developed. And we see these definitely as the beginning of many potential applications. Firstly, a domain manager where you can actually request a key over a web page for a subdomain of a zone that is enabled. Again, first come, first served. And if it's clear enough within the room, you can even actually try this live with the QR code displayed. Once a successful domain list is active, DNS update rights for this domain have been granted. And all resource records at that label or below can be changed by the key, including the addition of further keys to give any further people access to that domain. So collaborative domains become easy and possible in terms of ownerships. Okay, and again, I hope it's readable within the room. I know the text is small, but another GUI application that we have developed is a service discovery agent or inspector. Wide area DNS service discovery is basically an internet-wide version of the technology that allows you to find your own local printer on your own local network, but at an entire internet span. This application allows you to manage and display and find local services that are published by yourself and others within your local environment. Listed in there, and it's very tiny text. There are different types of services, from pure web services to FTP. For those old enough, we even enabled a test Gopher server, etc., as well as SSH. So it's a flexible system that allows people to publish and discover a whole range of different services, both within their own infrastructure and beyond. And the third example GUI that we developed was a collaborative mapping, allowing community networks and others to start to map resources, either mobile or static, within their domains of interest. This uses the DNS record, resource records of LOC or LOC, which is a resource record that allows GPS coordinates to be stored within the DNS system. So mobile nodes, such as mobile phones or other mobile devices, can constantly update their own GPS position automatically. There's actually examples of scripts that do this for Android devices. And they can also describe other services within that region. So it could be useful for community networks, for local services, either food delivery or transport services, etc., etc. And you can try this service live again with the QR code below. Yeah, so further to this, this example is one example of a mobile phone that is tracked by its own position within DNSSEC, using its own GPS hardware to update its own unique name. And you can actually define groups of different points of interest as displayed there as well, and they can be coordinated by a number of people who also have collaborative access to that domain. Okay, so the status so far with this project is we allow decentralized, scalable, and dynamic updates using SIG0 secure cryptographic pairs. We've developed the beginning of a API for web-based applications to use DNS infrastructure data. And we also include and have liaised with Freifunk to implement their DNS infrastructure and improve it to DNSSEC to allow for secure updates in this sense, and also allow for secure wide area DNS compatibility. The tools are easy to maintain. There's a core library developed in Golang, and there are classical bash scripts to illustrate some of the functionality. So very low threshold of requirements there. We have live services under beta-freifunk.net and beta-berlin-freifunk.net, and we've been involved heavily within the community activism here in Berlin at radio shows and meetings. The next step for SIG0 will be to implement the new standards as they've just been published, and also to start to incorporate this within OpenWRT router image. OpenWRT is the basis of many of the firmware offerings developed by community networking, including Freifunk. This allows for flexibility and the use of cheap reconditioned Wi-Fi routers within the network, and it also allows for further services. New supported services that we plan to offer will include WireGuard as a DNS SD service, which will allow point-to-point or topologies of internal or mixed VPN networks within community networks themselves. For further security of services, DANE and SSH FP records, which is a way of nailing SSH keys into DNS as a security measure for remote access, and as well as experiments in potential service load balancing and failover. And Alex, some of your presentation, I think, could slide well into this area. So I'd like to thank you all for your patience this morning, and if you have any further questions, there's a QR code and some interesting email links and web links there as well. I'd like to open the floor for any questions on this project.
Great, thank you so much. With the queue is starting to fill up. So Olaf, the floor is yours. And then there's a question in chat we can address afterwards.
I was about to
Okay,
say there's only one person. That's not really a full queue. But anyway, thank you, Adam. This is fascinating. I think in the 25 years that I've dabbled in DNS, this is actually the first production-worthy 6.0 deployment almost. I'm a little bit curious. I have two questions. First, when you create subdomains, I presume that's all within Zone. You don't delegate. You don't create a delegation to a new domain.
You can, and that's the beauty of it, because of course, once you have full RR control within a domain, you can potentially subdelegate and run your own DNS server below that point. This has not been practically demonstrated yet, and it will be something I would love to explore further, giving people the further autonomy to start raising DNS infrastructure within their own community if it is required. So I wouldn't rule that out necessarily, but I believe with all my heart that it is actually possible, at least with NS records. I'm not sure about the upcoming DELEG records.
Very cool. The second question is, I presume you use NSEC3 to prevent zone walking while signing, because otherwise the privacy issues are...
Interesting. I would have to actually check. That would be down to the DNSSEC implementation. So that would be implementation, domain implementation specific. I have found actually with my experiments NSEC3 to be extremely frustrating because of that property, but others see it as a security issue.
The reason why I bring it up is that with normal NSEC you have, maybe not for you to explain, but with normal NSEC you have zone walking. And given that you are putting location coordinates in the DNS, being able to find that through a very simple zone walk, I think has huge privacy issues. So hiding that behind NSEC3 makes perfect sense.
Very good point. Thank you for that. The one comment I would make is if you are installing your own software on your own phone to allow it to update and publish its own GPS coordinates, your intentionality is actually there to publish it publicly into a global database. When you wish to turn it off, then you can do so. However, I do understand that this would not be for everyone.
Yeah, it sort of requires people to read the terms of service.
Indeed.
All right, and in chat, Raquel asks, are the Freifunk meetings in Berlin open to new participants, and are they in English?
Yes, they certainly are. Thank you, Raquel, for the question. Freifunk meetings in Berlin happen at a unique hack space called Seabase, which is the oldest crashed spaceship on Earth, or so they claim. So yes, Freifunk meetings are every Wednesday evenings, first Wednesday of the month, and they are open for English speakers, such as ignorant Australians, such as myself. So yes, please, if you are based in Berlin, please come along to a Freifunk meeting. I should be there, and you can ask for me.
Okay, great. And then my question here is, this is all new to me, and so it's a very interesting system being described. I'm curious about the comparison with what I do know, which is sort of zero conf Vahi,
Yes.
sort of local dot solutions for addressing, which to me are entirely distributed, but presumably have significant structural differences to what you talked through here. So can you speak a little bit to the two?
Yeah, sure. Thanks, Curtis. Avahi is a tool that can be used to query wide area DNS SD. And in fact, it's one of the tools, not in this presentation, that I give examples of usage within 604. So yes, you can use Avahi browse to browse service discovery in a wide area sense. In fact, I think within the slides, there are 3 domains, zenario.com, betafreifunk.com, .de, and so on, freifunk.net, pardon me, where you can actually browse them at the command line. The actual web applications were more difficult to try and get DNS resolver generic DNS resolvers within the WASM sandbox. But the command line tools such as Avahi are perfect for it. Avahi handles the local multicast DNS services to find your printer, but also handle the unicast UDP protocols required to query remote DNS servers.
Cool. Okay, interesting.
So
I will
all
jump out of
standard
the
stuff.
queue. All right, awesome. Thank you so much, Adam. Fantastic presentation and very much in scope. So we're really excited to see this kind of work here at Gaia. Thank you for chatting.
Thank you for having me.
So next, and unfortunately last, as I think the slots are a little smaller at this IETF, is Ritu, who maybe is wandering to the front. Oh, yes, there she is. This is a. Oh. We're gonna have to figure out the presentation and slides bits. Let me take back slide control from Adam. Stopping slides, switching slides. Do you have a clicker up there, Ritu?
Yes, I do have.
Does it work?
Haven't checked it, and I'm not good at using clickers.
Maybe I have to give slides clicker slides control. Okay, does it work now? Not seeing slides move. Oh. Looks good. All right, if you're driving that, then I think we're in a good space. Can you get up to the microphone and make sure that we can hear you online?
Am I audible to you?
Oh, you're so clear. Okay. Perfect. Ritu, the floor is yours.
Thanks, Curtis, and thank you everyone for such a wonderful presentations that we have been through.
Oh, Ritu, can you get a little closer to the mic?
Okay. Thank you, everyone, and such a wonderful presentations prior to me, which were more or less like a community networks which have been presenting, and this is more appropriate time for me to talk about that why this presentation is important and why we are talking here. I'm Ritu, and I'm as a working chair group with the Internet Grades of Services in rural areas, especially working for this particular working group belongs to IEEE, Standard Communication and Standard Practice Sessions. This particular presentation is about the connectivity performance measurement for rural regions, and then we try to understand that why technical and social challenges in advancing the internet equity. Okay. I think it's too text heavy, but let me just break it down as what we are trying to do it, and then I'll come back that why are we doing it. We are trying to examine that the internet and connectivity performance measurements with the existing tools like a RIPE, MLab, or a proprietary platforms, UCLA and NPERC, and some of the state-owned platforms like in India, TRI has it, MySpeed, whereas some of non-governmental initiatives like ISOC Myra Pulse and the region-specific initiatives like AIORI that we are trying to examine to understand that what are the measurements that they are using it and what sort of technical and social aspects that they are covering through their measurement tools actually when we talk about the internet performance measurements or connectivity measurements. Taking a gap area. Like I was having a side meeting and someone mentioned to me that when you talk about internet performance measurement, it's more talk about a technical aspect of it, and we think about technical aspect of it. I said, yes, we do understand that it is a technical aspect, but let's come to the connectivity portion because it covers the more the social and the technical aspects, both the aspect it covers it. So I took the suggestion and changed it from the internet performance measurement to the connectivity performance measurement, because we are going to cover the social aspect of the connectivity as well. Why? Because it is important that when we talk about the internet and the connectivity, internet is a medium, but the connectivity is to how to provide a quality of a services along with the meaningful access and the meaningful how users are using it. So here we are trying to understand and measure the performance measurements, and with the small operators and the community level operators, which are based in a specific zone areas, we are trying to understand that what are the user-centric and locally appropriate and performance measurements. More coming with the real-time scenarios and the real users. So our effort is to understand that we are trying to answer some of the questions through this one. What are the standard performance metrics that are existing, are relevant to small operators? Do we need a small measurements in a region specific, or do we need to divide the urban and the rural centric measurements differently and see it together differently? We are understanding the metrics with the other services provided by the small operators. So small operators, we will come through with this one, and how this metric will help the small operators and village level operators to maintain the quality of a service. But the most important question comes here is, why are we doing it? Everyone is aware about that 2.6 billion population is unconnected. Mostly of them are from a global south countries. And mostly these unconnected population are served by small operators. And when we do say small operators, it does mean that operators which are working under the franchisees, also by the small level of operators like a community network operators. In many rural areas, these user experiences face a frequency, disconnection, latency, jittering, and the poor service quality. But most of these problems also get unreported, or because they do not have a specific tools to monitor it, or either not deployed or not accessible by them. Some of the challenges which I have mentioned already here, that some of these tools are heavily concentrated on urban-centric locations, whereas some of the tools require a specific devices or a specific devices to measure such kind of a performance, which is not feasible for a small operators to take it into their considerations. Coming to the part of that, why does it matter to the small operators? And when we are saying the small operators, it is a wireless internet service providers, community networks, or a local ISPs which are limited to their specific region or a community or a village level. And it can be a population size based on 1,000 population size or a 500 population size, but it depends upon the region to region. And that's why I have not mentioned that what population size that we are talking about here. For a small level operator, it is not a luxury to be a part of such metric system, but it is a strategic and an operational necessity to be such a system, because it improves the connectivity for them to be a transparent within the community, as well as helps them to the network planning, more shaping the inclusive regulation, which often they are discarded because of not availability of a context or a user-based experiences what they are facing it, and that's why they are almost not present in some of the policy regulations and the talks, and the high-level talks are always happening, which is not coming to the bottom one. As well as the user do not know what kind of a demand they should ask from their ISPs, and what kind of a services they should ask from their local ISPs, that they should be satisfied with their customer and they're satisfied with their user experiences as well. So we have a very common approach to this one. We have analyzed, so our working group includes members from the across the some of our global south countries like Myanmar, Nepal, Bhutan, Indonesia, Brazil, and so forth. Some of our contextual, when we started working on it, that our approach, we decided on our approach, which should be context sensitive, uh, technically feasible for a small operators. It could be easily deployed or adaptable by a small operator or any wireless community network operator. It should have an aspect of a user centric and are actionable to inform improvements in the connectivity, which also further leads to the policy and the funding arrangement for small operators, because small operators do struggle with their sustainable and they do struggle with the kind of a funding they receive. They are mostly dependent on the larger ones. What we are exactly doing it, we are mapping the where and the why rural internet performance is not being measured accurately. So we do say, I'll give you some a few of examples that we do say that some of a Mbps line, like 100 Mbps line or a 10 Mbps line is coming on your nearest hottest area, but when you take the output of it, it is not that relevant, or that 100 Mbps line. We may be receiving a 50 Mbps line. So those are some of the discrepancies which we see it, and that's the measurement tool, and that's the benchmark for us as well to start measuring those ones. We are going to highlight what are the technical and the social barriers that are preventing small operators from participating in national and global measurement frameworks. Uh, Also, trying to create a small, easiest and the affordable version to deploy, which can be deployed by such metrics by the small operators. This tool is more for operators to deploy and accept it, not to penalize them that we are monitoring them, but to improve their the performance in the connectivity measurements. These are some of the three main tools I have mentioned here, but there are a number of other tools that we are working right now, and we do understand these tools are covering the technical aspects of those ones. However, they are missing in the user-centric aspect. They are covering the DNS, client server, round trip time, everything else in terms of a technical kind of a thing, but they are also missing the sum of a power outage, power, electricity, and the sum of a social and user-centric approaches. Those are missing in those kind of tools. These are some three, but yes, we have other ones which we are analyzing it and comparing it with what technical things that we need to use it, and what social aspect in a rural context we should bring it up. Through this presentation, that we are trying to look for is to look for a case studies who would like to use this framework, and also when we have a framework, we would like to use this framework by the other network operators. That's the thing that which we are looking from this session as well. Thank you, everyone.
All right, thank you, Ritu. The queue is open. I'll give it a few moments before I jump in. Can you go back 2 slides, Ritu? Oh, I got Hannah is up. Hannah, floor is yours.
Hello, thank you. This is very, very important, but I see that you mentioned a lot of also societal aspects or social aspects related to these. Do you have specific plans how you want to measure these, or you just deduce them from the network performance and so on?
No, we do have an existing kind of parameters that we are trying to cover it. What is the like some of a parameters that we are looking from this societal kind of or a systems or a frameworks is what is the coverage area, how much population size they are covering, what kind of a services they are providing, and at what level the services are getting to be threshold, that what parameters that okay the services are providing. For example, the services they do provide is a free government services, or the kind of a premium model of a digital literacy services. But all those services that which we are bucketing in the list, that we are also trying to analyze that how important it is for the community and why it is important from a small operator aspect. And then some of the service some of our parameters that we are covering is also that where are they serving, are they serving a larger amount dense population, or a population which has a minimal population size, like a one village which has only 50 population size. Are they serving that, and what kind of a quality, like the bandwidth they are providing, are they also providing internet, or also they're providing the intranet services, whether it could be the other form of a community networks as they are using it, like a open BTS or a Wi-Fi hotspot, or some kind of a IVR based services that we have seen it is being used by community network operators, also all from a community radio station operators as well. So we are covering all those aspects into this one. Curtis, it seems to that you have to jump.
Yeah, I'm reading Raquel's comment in the chat right now, and I don't know if it's a question or not, but I guess not. But it's an interesting point. I guess it's an experience in Ireland. Um, but I wanted to ask, there's clearly kind of a two different perspectives in these kinds of networks. There's the sort of user side of this, which is often really intermittent, and this is over some microwave link off to the ISP somewhere, and like that part of it is maybe where there's the least amount of tooling. But then there's the ISP itself, which often has probably pretty good power because they're running production grade stuff with UPSs and the things like that. Um, and it seems like both of these are in scope for what you're trying to do. Um, do you have a sort of thought towards where your energy goes first? I could imagine saying, hey, let's go find some small regional IXPs and put some right probes in those and really try to get more measurement out into these frontier networks that aren't as well instrumented right now. Or I could see trying to do that sort of client side piece to get what I think is the hardest and most limited data right now. So kind of what's you all's headspace on how you're gonna I guess move first?
Yes, I think a very valid point. Something on the energy aspect, especially I'll give you the context from India and the South Asia perspective, like energy and the conservation of use of solar enabled routers and some certain kind of a thing that we are trying to uh, see that how many of them are using it, but and if they are using it, what level they what sort of it, maybe there are also the some of the solar based routers are also not so much equipped with maintaining the energy balances. But when we talk about the power and the outage kind of a thing and the voltage, that we will be measuring with the some of our environmental aspects, especially in geographical areas, to considering the geographical areas of mountains and the coastal region. These are the two geography barriers that we are trying to measure it. Uh, Definitely on the side of this one, that's the also the request from the people here, that we would like that if anyone could come forward and measure, take this tool and measure in their performance network, so that we can share with we can have a more interactive and a participative environment for having such tool more inclusive for that approach. So uh, but also we need to check a lot of other things in terms of environment and the climate as well. when we talk about the connectivity measurements.
Okay, cool. So would anyone else like to jump in? Otherwise, we might call it for this. I do want to call out specifically this last bit. Ritu is asking for case studies, and I think the community networks set here would be a great resource for bringing in some of this measurement infrastructure. Jane would like to step in. Jane, what's up?
Ritu, I think it might be there's some folks in the local broadband mapping community in the US that may be able to work with you because they're looking at different measurements themselves, because some of those communities were left out in the mapping exercises a few years ago, and they were also looking at different network modalities. So we can put you in touch with them.
Thanks, Jane. I think that would be great.
And so, Ritu, if you don't mind, maybe a thing for you to do is put your email address in the chat,
Yes.
so that people can find you and reach out if they're running a network and would be interested in engaging in this.
Yeah, Curtis, I'll do it. Yeah.
Okay, perfect. But otherwise, that is our three speakers for our set here. We're ending a little bit early, which is always nice. I get to go back to sleep. I'd like to thank Ritu, um, Alex, and Adam for presenting. And otherwise, we will see you all in Montreal, hopefully in person. It's nice for it to line up well with or better at least with our time zones. So unless anyone has anything they'd like to jump in on the end here, y'all have a good day and enjoy the, I think, last day of the IETF. Hopefully you get to get out into town and do a little bit. Thanks, everyone.